In the next couple of lectures, we want to set up some Niagara systems and the logic to spawn those particles for when our apples get destroyed and when we lose a petal. We will begin by setting up some particles and the spawning of those particles for our apples. I will play here for a second. Now remember that our apples get destroyed for 3 different reasons. Firstly, when we catch an apple, that is, when the apple hits one of our petals. Second, when we lose an apple, that is, it falls too far and we won't be able to catch it. Thirdly, when we clean up the game at the end of the game, we search for any remaining apples and we destroy those. So from this we can see that whenever we destroy an apple, we want to spawn a particle system. Now we want to try and set up the logic for the particle instantiation in one place and not where each condition is reached in the code, because that is going to be some duplicated code. Thankfully we do have a virtual function that we can override for this. So let's open up Visual Studio and navigate to the apple base header file. The function we want to override is virtual void destroyed. Next, we want a pointer to a Niagara system so that we can specify the system that we want to spawn from within the editor. I will name this pointer apple destroyed particles. Forward declare that with the class keyword, otherwise we will get some strange errors. Decorate that with the U property and specify edit anywhere. Put that in a category such as particle effects and maybe blueprint to read only. Quick actions and refactorings and create the definition of the destroyed function. In the definition of destroyed, we want to call super destroyed. Then we want to check if that apple's destroyed particles is not null pointer. The function we want is in the Niagara function library. We need to include the header for this, that is, pound include Niagara function library header. Again, we can get this from the documentation. Now notice that we get an error here, cannot open file. That's because we actually need to include the Niagara module as a dependency for this project. So let's open up the applepicker.build.cs file. In the public dependency module names, let's add the Niagara string. Go back to the apple base source file. I will close off the Unreal editor and build. Let's try again. We want the spawn system at location function. Now it may be best to refresh your project when you add a dependency module. IntelliSense may not update and you may get red squigglies even if the build succeeds. This makes it difficult since we can't see the parameter list. I will save my changes. Right-click on the project name and open folder in File Explorer. Navigate to the root of the project where we can see the solution and project files. Close off Visual Studio. You can delete some of those files such as the .vs, intermediate and binaries to clean up and refresh the project. Then regenerate those. But for this I'll just try to right-click on the uProject file and generate Visual Studio project files. Then open up the Visual Studio solution again. Back in Visual Studio in the Apple base implementation, we should no longer get the error where we have the Niagara function library included. Also where we try to invoke this function, spawn system at location, we can get the parameter list now, Ctrl Alt and spacebar. Provide this for the world context object and your apple destroyed particles pointer for the Niagara system pointer. And of course we can use get actor location to get the actor's current location, that is for the third argument. We want to spawn the specified particle system at the apple's current location in the world, that is right where it gets destroyed. We are not concerned with the other parameters since those have default arguments. Auto destroy is set to true by default, for example, that is what we want. Auto activate is also set to true by default, that is also what we want. So you can specify those explicitly otherwise if you need to. Same with the scale and rotation, but we can use those defaults for our purposes. So this is the logic to spawn the Niagara system at the actor's current location when it gets destroyed. There is one more check that we can do, so I'll demonstrate that. From our pointer, we can use the isValid function. This will return true if the system is valid and can be instanced. And with that, let's build and run. Let's open the Apple blueprint. We can specify a Niagara system now. But we don't have one defined yet, so let's define a basic system for that. I will dock the content browser for now, and under content, let's create a new folder. I will name that Niagara. Open that folder up. Let's right click in here, and then in the Create Basic Asset section, let's choose to create a Niagara system. I will choose New System from selected emitters. Click Next. Now here we have a number of templates to choose from. I will select the upward mesh burst and click the plus button. That will add that emitter. Click Finish. Let's name the Niagara system something like Apple's Destroyed Particles. Double click on that to open it up. This will open up this Niagara editor. Now this is not a Niagara tutorial, so we'll simply change some of the existing parameters until we get some particles that we like. Again, we just want to create some basic programmer art for this. In the preview to the left, we can see the results that the system generates. And at the bottom of the editor, we have the timeline where we can play, pause, and so forth to closely inspect the results that we get. In the System Overview tab, where we have the nodes, basically, we have this upward mesh burst. Now, we will modify some parameters on this. To begin, let's select the Mesh Renderer and search for the Meshes section. Click on that, and here we can see this arrow mesh is specified, but let's change that to a sphere, such as our Apple static mesh. In the preview, we can see that the resulting effect updates. Those spheres are large and white. In the material slot, we will keep the one that is currently assigned. We will change the color elsewhere. Next, in Add Velocity, I will change the velocity speed maximum to 50. The settings that I'm changing is based on testing, so you can play around with different settings to get a result that you like. I will also change the velocity mode to From Point. And again, this is a matter of iteration, changing the settings and then inspecting the preview window to see the results that you get. So again, for the velocity mode, I will choose From Point. Go to Initialize Particle, and then under Point Attributes, I will modify the color. We want the color to match the color of our apple. So we could open up the Apple material and copy its RGB values. For example, you can right click on the fields here to get the option to copy and paste, or just use keyboard shortcuts Ctrl-C and Ctrl-V, Ctrl-C to copy, Ctrl-V to paste. An easier way is actually to open up the color picker and to copy the X value from the material instance and then paste that instead. We don't want the particles to hang around for too long, so let's change the lifetime min to 1 and the lifetime max to 1.75. I also don't want the particles to be too large. They should be about the size of the apple, with some of the instances being a bit smaller maybe. I will change the Mesh Uniform Scale min to 0.3 and the Mesh Uniform Scale max to 0.7. Again, this is based on testing, and this is the result that we get in the preview now. Currently, there are too many instances, we don't need that many, so we will reduce that next. Let's go to the emitter update. In here we have many settings. What manages the life cycle of the emitter, for example, so when it gets destroyed and so forth. We will leave this at self. We also have the loop behavior. Once is fine, we don't want this to loop. And various other settings such as the loop duration and mode. All I want to change here is the spawn count. I will reduce the spawn count to around 7. Now we get the simple cartoony mesh pop effect. Compile and save that. Go back to the Apple blueprint. And under the particle effects category, let's choose that Apple destroyed particle system. Compile and save. If we play now, when an apple gets destroyed, we get that simple particle effect spawned into the level. To wrap up, let's look at the results that we would get if we use the default mesh scale attributes. Go back to the Apple destroyed particle system, and let's select the initialize particle, and let's reset the mesh uniform scale min and max. Compile and save. If we play now, those particles are much larger. That is why I reduced that, so I'll just set that back to 0.3 for the mesh uniform scale min and 0.7 for the mesh uniform scale max. Compile and save. And that is it for the Apple destroyed particles.